All right, so we already know that a triangle has 180 degrees. So let's start filling this in here. So a triangle has three sides, and if we start in one corner and we go to the other corners, we can see that we only get one triangle there. And the interior angles, and that means the inside angles of a triangle, these all add up to 180 degrees. So these polygons here are regular polygons, and that means that all of the sides are the same. So if I wanted to know just the measure of one of these angles on the inside, I would do 180 divided by the number of sides, and that's going to give me 60 degrees. So each interior angle here is 60 degrees. So for this square, if we start in one corner and we go to the other corners, we can see that it had four sides and we got two triangles. So this is 180 and this is 180. So altogether that adds to 360 degrees. And if I wanted to know just what one single interior angle would be here, because it's a regular polygon, if I want to know just the measure of this angle, and we already know what it is because it's a square, but let's go through just so you see the pattern here. So we have 360 degrees divided by, and there's four sides there, so there's four angles there, and 360 divided by 4 is 90 degrees. So each angle on the inside here is 90 degrees. All right, so here we have a regular pentagon. So all of the sides are the same, and there's 5 sides. So there's 5 sides. If we start in one corner and go to the other corners, oops, that was a bad one. All right, how many triangles do we get? You get 3 triangles. So the number of degrees there, we would do 180 times 3, and that's 540. So we are going to do 540 divided by 5 to figure out what one angle is. This is 5. 5 goes into 4 0 times, and it goes into 40 8 times. So it's 108 degrees. So this is 108, this is 90, and these are 60. This hexagon, we have 6 sides. Let's see if we notice a pattern here. When we had 3 sides, how many triangles did we get? Just 1. When we had 4 sides, we got 2 triangles. When we had 5 sides, we got 3 triangles. Can you guess how many triangles we're going to get when we have 6 sides? All right, let's try it and see if you're right. So we start here, we go 1 to each corner. All right, how many triangles did we get? 1, 2, 3, 4. Were you right? All right, so there's 4 triangles there. So we would do 180 times 4 to figure out how many degrees are in a hexagon. So there's 720 degrees altogether in a hexagon. And if we wanted to know the measure for just one of those angles, because it's a regular polygon, all the sides and all the angles there are the same, we would do 720 divided by the number of angles. So 120 degrees for each of these angles here. All right, do you notice the pattern now? If you didn't see it before, do you see it now? The number of triangles is always 2 less than the number of sides. So if for the next one that we have down here, there's 8 sides, how many triangles should it have? It should have 6 triangles. So let's start in one corner and go to all the other ones. I'm going to make this one a little bit better. That last one keeps getting me. All right, so there's 6 triangles here. So we would do 180 times 6. So we get 1080 degrees in an octagon. And to figure out what each angle is, we do 1080, and there are 8 sides in a different color because I'm starting to get into my other space up there. So 8 goes into 10 once, 8 goes into 28 3 times, and 8 goes into 45 times exactly. So each angle here is 135 degrees. All right, so there's a formula here for this. The way we can figure out the number of degrees in a polygon is we do the number of sides, which is n, take away 2. That's going to be how many triangles we have. The number of sides, take away 2. And once we know how many triangles we have, we just multiply that by 180. So this is the formula for the number of degrees in a triangle. Number of sides, take away 2, and then times 180. So that's one way you can figure out the angle, an interior angle of a polygon. Let's check out another way. All right, I'm going to zoom in here a little bit. Okay, so looking at this triangle here, if we extend the side of the triangle, I'm going to go like this. All right, this would be the interior angle. I'm going to call it I for interior. And this would be the exterior angle. I'll call it E for exterior. And if I keep going in the same direction, interior, exterior, interior, exterior. If you notice here, all of these exteriors, we go here, we go here, we go here. We are making a full turn all the way around a triangle. And if I measured those degrees and added them up, it would add up to 360. So the sum of the exterior angles is always going to be 360 degrees. That will be true also for the square. So let's just extend these sides. So interior, exterior. If we add up all of these exteriors, and because it's a square, we know that every exterior here is 90, because if the interior is 90, the exterior is also 90. 9 times 4 is 360. But it's always true that the sum of the exterior angles is 360. So you extend a side, and you'll have an interior angle and an exterior angle. And what do they add up to when you put them together? Do you see that they make a straight angle when you put them together? So these two angles here, the interior and the exterior, are supplementary. They add up to 180 altogether. All right, so if we wanted, so the other way we could figure out the measure of these interior angles is we could use the triangle method, which was the first way we talked about. The other thing we can do here is we could say, okay, every single polygon has the exterior angles, the sum is 360. So to figure out the measure of a single exterior polygon, we are going to do 360 divided by the number of sides, and here it is 3. So 360 divided by 3, that's going to be 120. So a single exterior, I'm going to write it over here so I don't get into the single interior space, is going to be 120 degrees. So the exterior angle here, I'll just go to this one, is 120 degrees. So do you see how I could figure out the interior now? since they are supplementary, I could do 180 take away 120, and I get 60 degrees. All right, let's keep going with this down here now. So for this square, we know that if we add up all of these exterior angles, we're going a full turn around it, it's 360 degrees. So to figure out one single exterior angle, we would do 360 divided by the number of sides, or the number of angles there. There's 4. So 360 divided by 4, that's going to be 90 degrees. So I know that each exterior angle is 90 degrees. And those are going to add up to 360. And that also helps me know now I can figure out the interior angle. If this is 90 degrees, 180 take away 90 is 90. So that means that this interior angle is also going to be 90 degrees. For the next one, let's look at our pentagon. How many degrees is it going to be if we add up, if we extend the sides here? If we add up all of these exterior angles, we are going to get 360 degrees. So if we want to know what the measure of one exterior angle is, we do 360 divided by, and there's 5 sides here, 5 angles there. So 5 goes into 36 7 times, and then into 10 twice. So we know the exterior angles are all going to be 72 degrees. So the interior angle here is going to be 180 take away 72. So it's 108 degrees. For the hexagon, again, if we extend all of the sides of the hexagon, and we add up all of those exterior angles, those are all going to add up to 360 degrees. To figure out the measure of one exterior angle, we do 360 divided by the number of sides, which is also the number of angles, which is 6. 6 goes into 36 6 times. 6 times 6 is 36. It goes into 0 times. So each exterior angle here is 60 degrees. So to figure out the interior angle, to figure out this one, we're going to do 180 minus 60. That's 120 degrees. And last one, the octagon. Extend all the sides. Looks kind of cool, I think. 1, 2, 3, 4, 5, 6, 7, 8. So there's 360 degrees if we add up all 8 of those angles. To figure out the measure of one exterior angle, we do 360 divided by 8. 8 times 4 is 32. So one exterior angle here is 45 degrees. So to figure out the interior angle, we have to find the supplementary angle for that. So we do 180, take away 45, and we get 135. All right, let's take a look here. And we can see that we got the same, let me grab a highlighter here. So we got 135 for the interior angle when we did it with the triangle method, and we also got 135 when we did it for the octagon with the exterior method. We got 120 with the triangle method for the hexagon, and we got it with the exterior method. And for the pentagon, we got 108 degrees, and the exterior method, we got 108, square, we got 90, and triangle, we got 60. So you could use either method to figure out the angles of the interior angles and then you could use the triangle method or the exterior angle method. And just a quick little side note here. If you wanted to know the exterior angle of a pentagon and you found out the interior using the triangle method, you could also do 180, take away 108, for example, and figure out the exterior that way too.